are still in the same section. Remember we began this section with the limit thing that we talked about in section 2.2? So the very beginning of this, we had this result from section 2.2. The limit as theta approaches 0, sine theta over theta is equal to 1. Okay, it's something we saw back then. We were using graphs and charts to figure it out. Now we can accept it as true. It turns out that as long as theta is approaching 0, so as long as it's sine of 0 over 0, this is true. So if I said like the limit as theta approaches 0 of sine 2 theta over 2 theta, that's also going to equal 1. Because if I'm approaching 0, 2 theta is going to 0, 2 theta is going to 0. These have to match in order for it to work. So if it's a 2 theta for my angle, I have to have a 2 theta on the bottom. So this is kind of a result of limits. We are just going to practice using this today to evaluate some limits that we would not otherwise have been able to evaluate. So, what was that? If I just tried to plug in 0 here, I would get sine of 0 divided by 0. Can we do that? No. All right. If I can get the argument to be the same thing that's on the denominator, then we can simplify it. So, let's think about rewriting this. So we have a sine of 7x. So what do I need to be on the bottom? 7x. A 7x. Currently I have a 4x. So what I'm going to do is say, okay, I want the x here. I don't need the 4. So can I just pull it off to the side?
Yes, you can.
It's multiplied, so if I multiply this back, I get back where I was. What do I need with this x? So if I'm going to add a 7 on the bottom, I have to put 1 on top as well. So that way they would cancel each other out. Okay, so I am rewriting my problem, but we need to understand this is equivalent to what I started with. If I multiply this together, I would have 7 sine of 7x over 28x. It would reduce, and I'd get back to where I started. So I haven't changed my problem. But now, this is a limit I can do, because we can do each of those limits individually. What does this one approach? 1 times, this one doesn't have an x in it, so it's just a coefficient, so it just stays. So this approaches 7/4.
Okay. Now we do.
Wait, the limit of a number is 7/4.
Remember, the limit of a constant is a constant.
I thought a limit. Oh, that's derivative. Sorry.
Yeah.
Okay.
Couple things now. Ooh. Okay, let's go with this one.
Did we do tangent?
We did not have a result for tangent.
Okay.
Okay,
Tangent is sine over cosine.
what is tangent of 0?
Oh, tangent is 0.
0. So it's 0 over 0, so can I just plug in? No. But you commented that tangent is sine over cosine. And this is all over x, or you could say x over 1, right? I may be showing a few more steps than I need here, but I want you to understand what's happening. If you're dividing fractions, we multiply by reciprocal, so 1 over x. Alright, so far I have not added anything into my problem, I've just rewrote it. Now, we're not adding, we're multiplying, so
We get that cosine out of it.
So what I'm just going to do is reorder. Since it's multiplied, I want to put the x in this one and the cosine 3x over here. Because doesn't this multiply to the same thing?
Yeah, sure does.
Yeah. Okay. If this is a 3x, what do I need on the bottom?
A 3 and a 3 on the other
So if
one.
I put a 3 on the bottom, we need a 3 on the top, so they would cancel. Then, properties of limits, sine 3x over 3x is going to go to 1 times over, if I plug in a 0, what's the cosine of 0?
1.
So 1 times 3.
Is that the amount, like, the bottom half, is that the amount of work we have to show after we do everything, to show that we,
Yeah, so just showing me.
Okay.
like, we don't have to rewrite the
Let me
limit
lock in on
separately?
this next one.
Because if you plug in a 0 for your x, 3 times 0 is 0. Cosine of 0.
Oh, it's fine. Yeah, I know
Yep.
it's fine.
Alright, is that one okay?
Oh, yeah. I got this one.
Okay, what's the answer?
1.
Alright, how'd you get it?
Because that would be the same as sine theta times sine theta. And the bottom would be theta times theta.
Okay,
So-
sine squared means we have 2 sines. On the bottom, theta squared is theta times theta. So, could you, I'm assuming you separated these?
Yeah.
And the reason we're allowed to do this is it's all multiplied, right? We can multiply in any order, we're just multiplying tops, multiplying bottoms. So if I multiply this, I still get sine squared on top and theta squared on the bottom. But if theta is approaching 0, sine theta over theta goes to 1 times sine theta over theta. 1 times 1. Okay. Take a second and see if you can figure out the next one.
I
I can
don't.
Here we can separate them off. So we have the limit as z approaches 0 of sine 2z. I'm going to put the z with this one. I don't need the cosine, so it's just going to come over here by itself. Okay, but if this is a 2z, what do we have to have on the bottom?
2.
So if I'm adding a 2 on the bottom, we have to put 1 on the top so that our problem is still equivalent. Okay, so our limit rule, since this is sine of 0 over 0, that goes to 1. Over here, we have 2 over. If you put in a 0, 3 times 0 is 0. Cosine of 0 is 1.
So, okay. So is that being like, the 3 would be the beta here?
It's multiplied with the theta. If you think about
So the z is the
It would
theta,
be
yeah.
undefined.
like the argument is 3z. If you think back to graphs of cosine, for instance,
Unless you try to make
this
it.
is what your cosine normally looks like, right?
If there was like.
When you
Or,
put
yeah,
a
yeah.
number in
You
front,
try
it
to make
changes
it,
the period. It's making this thing repeat
Just like
faster.
how we put it.
So,
Yeah.
it's like looks
Yes,
like
that would
this,
be
but it
flowing
still
if we had
starts
to
at
do
the
that.
same point. So we're still getting.
So my plug the 0 into the z, not, I don't do,
think
I
we're
don't
ready
do
for
the 3 at the end, I
hard
do
ones.
3 first.
Right,
Okay.
because it's the argument. So order of operations. 3 times 0 is 0. The cosine is 0. Okay. How many fractions do I need this one?
All of them.
3, I mean, is the number I meant.
Okay, so we have a sine 3 theta squared. So can I make 2 fractions each with a 3 theta? Okay. The bottom. It's all multiplied so we can break it apart. Each of these sine 3 thetas will have to be over theta. So I've got 2 thetas. I could put 1 with each. Does anything need the cosine? So let's just make an extra fraction with the cosine.
Oh, but you have to make it.
Big
Would it be
9,
9?
right?
Are you guys with me to this point?
Sure am.
So, in order for this to work, the argument has to be on the denominator. So I need sine 3 theta over 3 theta. I'm going to put a 3. I have to put one on top somewhere, so I'll put it over here. This one also needs a 3, so there's another 3 that has to go on top. So then, this goes to 1 times, this goes to 1 times, over here, on the top, 3 times 3 is 9, over the cosine of 0 is
1.
9.
I'm liking
Is
these.
this where you get, like, is this lesson where you get your biggest enlightenment moment? From your class?
How-
Would-
Uh,
Were you able to just drop the theta squared?
I separate it into theta times theta. It depends on the year, actually. It seems to be clicking pretty well with this. You wanna try the next one?
Oh, yeah, I'm locked in.
This seems,
Where, that's such a rainbow.
that's the same.
Yeah,
That's the same.
Like a red herring is like it's a misleading thing.
Maybe like a fox or something.
Yeah, like,
no, it's a
No,
red
they
herring.
say that in a series of unfortunate events. That's why I know that. That's fine. I don't like cars.
I just know it.
Like
Come on,
red
like
herring.
silly.
Red herring look like salmon. I think it is. Like, they look like a certain
Now
type
am
of
I
fish. When you
getting
catch a
grilled
red
over
herring,
using
you
the-
catch a fish. You think it's something
The
else.
red herring.
It's just like a misleading blue.
So since this is assigned to theta, what do we need on the bottom?
Two.
Which means I have to put one on the top. Okay, but that's all we have. We don't have any other extra stuff. So this goes to 1 times, this is just like a 2 over 1 or 2, and 1 times 2 is 2.
Yeah, it was
How
falsified.
was that like for red?
No,
Cause
He was just
Said
expecting
thought
a
like it
trick,
was.
but there wasn't
Yeah,
one.
I was saying if there's an expected trick, then it's not a trick, then it's a red herring.
No, it's not what red herring.
Okay, let's do calc.
Okay, so now
We'll have
we
to
have
dive
to.
into English later.
What do you mean, you've been doing?
Oh, we've been calculating.
So,
Oh, I know how to do it.
okay,
We divide instead of multiplying.
okay. So, I heard a couple different options there both work. So if you think of them as each over 1, then if you flip and multiply, you have sine 2x over 1 times 1 over sine 5x. Are we okay with that? All right. We need some stuff.
You need 2 on 2x on the bottom.
Okay, this one needs a 2 and an x on the bottom, right? Okay, so if I'm going to put a 2x on the bottom, I have to put a 2x somewhere on top. Do I need a 2 anywhere else? So I'm going to throw it off by itself. Do I need an x anywhere else?
Yeah, on the top of the.
Okay, I need it to go with this sine of 5x.
Why wouldn't you put the 2 over sine of 5x and then the x on the other one?
That's what she did.
Say that again?
Like, why wouldn't you put the 2 over the sine of 5x and then x just by itself? Like, why is it that in that order?
Because we need the x for the 5x on it.
If you put a 2 on this one, in order for it to work, it has to be 5x over 5x. So the 2 would just, I would have to pull it away later on. Alright, so the first one, is this in good shape?
Oh, that's.
Yes, because my angle and my denominator match. Okay, over here, this is a sine of 5x, so I need a
5.
5x with it. If I put a 5 on the top, I need a,
5 on the bottom.
okay. So this goes to 1. Technically, this doesn't quite match our rule, but it actually works both ways because what's the reciprocal of 1?
1.
The reciprocal of 1 is still
Still.
1, isn't it?
Yeah.
1 is like 1 over 1, so when you flip it, it's still 1 over 1. So this works for the reciprocal as well.
That's probably easier.
And then this 2/5 is just 2/5.
Is it like a coincidence that the answer always seems to just be most of the time what's on
Cause she's put an easy one.
what the
there.
fractions are?
No, it's not truly coincidence, but you can't just assume that's what the answer
Oh,
is.
yeah.
It doesn't always. If I put extra stuff in the problem, it doesn't. Okay. One more.
Oh, yeah.
Okay. I just plug this in. I have 0 times cotangent of 0 is undefined. So I can't do that.
Well, cotangent is cosine over sine.
Okay. So this is x times cosine x over sine x. over sine x and cosine x over 1. What does x over sine x go to when x is approaching 0? 1. What's cosine of 0?
There's one, so
1 over 1, so we just get 1.
just one difference.
Wait, so if we were to plug in 0 then for the x's, we just ignore the x in the numerator?
Well, that's why we are not truly plugging it in. Because if I put in 0, this is 0 over 0, which we don't know. So that's why it has to be this combination with the x and sine x. It's a special case. All right, question 6. So, here's what you need to do. Homework is the day 3. You have a lot of time left. When you finish, I want you to study the trig derivatives.
Oh,
So remember 6 trig functions. You need to know the derivatives of all 6 trig functions. So use any extra time to work on memory.